Good evening, everyone. I didn't want to make you wait any longer because wow, I didn't notice. I swear to God, I didn't notice that we have reached 101 followers. Wow, I honestly cannot believe it. I'm just thinking I should have started this earlier. Honestly, oh, it's so good. It is. It is so good. No, I will not forget about my A level students. Of course, I will not forget about my A level students. I was just checking if anyone in A level is joining because lately I get very poor, very poor audience when I talk about A level. I think people just get bored and run away. Um, Wait a second, guys. I need to close my Twitch. Oh, my Twitch has been a very long day and a very bad day. But hey, now you are making my day. I need to close my Teams because I have lots of people writing in there. All right. The physics exam was so bad. Why? What happened? What happened with the physics exam? What was the problem? What did they ask? What did they ask in the exam? I have heard that it went quite good. Oh, so I was in a job interview. I applied for a different role in the school. That's why I was not in lesson today. Okay. The 6 mark was about the specific capacity. That's good. That's good. No, I will not be head teacher, and I don't think they're gonna give me anything else. To be honest, study leave. No. I didn't leak anything. I actually I don't think I got it. So I will not be anything. No, you're not gonna have study leave. You're gonna have reduced timetable, and that's a leak. That is officially a leak. Okay. All right. Very quickly. Let me do a poll just to see what do we have in here. Do we have? No, it's not exactly study leave, and I never say study leave. We're gonna have reduced timetable. Okay, reduced timetable. Let me see if I can. I thought I know how to make pools because I want to see what I have more A level, more key stage 4, more key stage 3. Yeah, I'm not abandoning you yet, and I don't think it's gonna happen in the following month. So that if that's what you worry about, you should not worry about. And we will always have a stream and Twitch for us. Okay. Sorry for the ads. It's really not my thinking. Okay, so it seems that we have a few A levels in here. Could they please show themselves? Like, make yourself notice. I will not be the head teacher, guys. Sorry, that's not even the role I applied for. They are taking it completely wrong. Anyway, hello. Okay, so we have one A level. Oh, today was a difficult day, but I'm still happy. No head of science. Mr. Robinson is a fantastic head of science. Anyway, so we have one sixth form. That's all. And we only have one sixth form. I thought we have at least two. Okay, so no. You are so nice, guys. I'm not that good. You are just exaggerating a little bit. Okay. No. Most probably no. They didn't tell me anything, but I don't think so. Anyway, let's talk about physics, which is what brings us in here. Okay. So I wanted to talk about hello. I wanted to talk about radioactivity, okay, because year 10, it is relevant for all years. As I always say, everything I talk about is relevant for every single one who is studying science. But you know that year 10, they will have their mock exams pretty soon, and they will have to do the topic on their own. So that's why I was thinking about. And plus, I really like radioactivity topic. But I think we have some sixth formers in here. So, yeah. I know nuclear fission can be confusing at times, okay? But I wanted to start before about with something a bit more basic at the beginning, which is about isotopes. So I'm not sure if... Probably I will start with talking about radioactivity, and then I will go to the A levels because they are a bit older, so they can stay a bit later. I think that is what I'm going to do. I think that is exactly what I'm going to do. We're going to talk a little bit about radioactivity, and after that I will go and help your older brothers and sisters, because tomorrow is physics A level exam, paper 2, and probably what they really need at this point is some one-to-one, and obviously with all the audience in here it will be a bit difficult. So that's what I'm going to do. I will talk first about radioactivity, and then I will go and talk about physics 11. Okay? That sounds like a plan. All right. Let me now change the camera and go to the camera, boom, in here. Okay. So, here we go, my beautiful paper, okay? I want to talk about the origin of radioactivity. And in order to do that, I first need to talk about a concept. I think I have already talked about this, but it is about isotopes. Isotopes. The set-up tour. What is the set-up tour? I don't know what is that. Talking about isotope. What is an isotope? Okay, I will give you two examples, okay? Here we have two atoms of the same element. Yes. Okay, CG man. Shall we meet at 8:30? Yes. Give me half an hour to talk to your younger brothers and sisters, and then I will give you my full attention to only A level. Okay? Is that okay? My little down quirk? Yes, yes. I need to set the lights. All right, I will take that little... all right. Yeah, that's true. You know, Spanish people, we are always late to everything. Anyway, let's talk about these two atoms. As you know very well, what element, the symbol is the letter C. You know this very well. Is it element? Anyone? Carbon, thank you. It is carbon, all right? So what is the difference between these two atoms? Because, no, not carbohydrates, carbon. No, I'm not becoming Spanish teacher. All right, we see that both of them, they have the same atomic number. Atomic number. Ooh, the red color is not very visible. Atomic number. All right. If you remember, the atomic number is the amount of protons. So then, what is the number in here? This is the mass number. And what is the mass number then? Is the number of protons plus neutrons. And this is, regardless, you might think that is not relevant. It's actually quite relevant, because this one, the one in here, carbon 12, is the element you are all made of, and is stable. Well, diamonds are also made of this. Meanwhile, this one is radioactive, but it's still useful because we use it in archaeology. I don't know if you have ever heard about carbon-14 test. Is using this radioactive isotope. So look how only 2 neutrons different. This one has 8 neutrons and 6 protons. This one has 6 neutrons and 6 protons. 2 neutrons difference is massive relevant, because it makes one radioactive and one non-radioactive. But let's stop in here 1 second, because we're talking about radioactivity. But what is radioactivity itself? It's when we have one element that it is unstable, like many of you. It's not stable, it's unstable. And in order to get that stability, they give out energy or particles. That's the point of radioactivity. So when we have an element, let's say carbon-14 or uranium or plutonium or any of those radioactive elements that you have at the bottom of your periodic table, when they emit radioactivity, it's not because they are bored. It's not because they don't have anything else to do. They emit radiation in order to become more stable. That is the whole idea. That's the whole point. And once they have released that energy and they have released some particles, they have give out some particles, they become more stable and they are not radioactive anymore. Okay? That is super important. In the chat, you asked me what is the definition of isotopes. So I'm going to just write it down, okay? Isotopes are atoms of the same element with same amount of protons. You can also say atomic number. It went out of the camera. Atomic number, but different amount of neutrons. You can also refer to it as mass number. All right, that is an isotope. And there are some isotopes that they are stable, and there are isotopes that they are unstable. The ones that they are unstable, we say that they are radioactive. I don't know about blisters, or I can research a little bit. Okay? No. It's a fair question. It's just I don't know the answer. No idea. It's something we need to investigate. Okay? Now there are three. 1, 2, 3, 1, 2, 3. I didn't set any music today, guys. You didn't notice that there is no chill music today. What an absolute shame. Sorry. This one. Nice. A bit of jazz background. Okay, fine. So, there are three types of radioactive decays, or let's say manners. Three manners that one isotope can emit radiation, okay? And they have a Greek name, and I'm sure you're gonna love it because it's something you use quite a lot, okay? So, there are three radioactive decays. And they are called alpha, like some of you guys, beta, like also some of you, and gamma. Those are the three types of radioactive decays: alpha, beta, and gamma. Okay? Alpha, beta, and gamma, which stands for A, B, C in the Greek alphabet. That's all. I always say, scientists, we are not very creative with the names. Okay? We are a bit lazy, I have to say. So it's just alpha, beta, and gamma. A, B, C. Alright? Are they similar? Not at all. Not at all. And I want to talk briefly about each of them, okay? Alpha is a fat particle. It's a fat particle. It's a big particle, okay? It's a particle that is made of 2 protons plus 2 neutrons. So it's a very, very fat, large particle, okay? Beta is a high speed and high energy electron. But I want to stop in here 1 second. Because if you just say that beta particle is 1 electron, they will not give you the mark. Why? If you remember, where can we find electrons? Orbiting around the nucleus, like similar to a planetary system. However, beta particle comes out from the nucleus. So it's not, the beta particle is not where you would expect to find the beta particle. It's actually like a bullet. I need more bullets. You can cut it in there, David. You can cut there. I need more bullets. It's like a bullet that comes out of the nucleus. That's the beta particle, okay? And then gamma is electromagnetic radiation. It's not a particle. So gamma radiation has no particle. You might think that if there is no particle, it's harmless, but actually gamma radiation is the nastiest one, because it's the one that is able to pass through your skin, through your bones, through walls, through almost everything, okay? It's probably the one that is most dangerous. Out of the three, gamma is the one we need to be more protected from, because it's the one that is the most dangerous, okay? I have a quick video to show you. Let's watch it together and we can comment it, okay? Yes, and we were 20 and now we are 9. So clearly I am being a bit bored today. Don't you think so, guys? I think I am getting a bit bored and people are not into the mood today. I don't know. What can I say, guys? What can I say? Maybe people are not into radioactivity. Maybe people don't like radioactivity. Why my internet is not working? Ah, here it is. All right, sorry guys. In the meantime, why don't you... well, that's something I wanted to discuss with you guys. Do you think it's worth it to keep having lessons during half-term break? I will not be in the country. I will be abroad, but I could take the laptop with me. Do you think that's something I should do? What do you think? Please, my Twitch specialist and Twitch strategies, could you please talk about what they think I should do? What do you think I should do? "24 hours a day." Come on, guys. I thought you liked me. I thought you liked me. 24 hours talking, I will get tired. Plus, if I'm traveling, I would like to see the place I'm traveling. I will visit the United States. Would you like me to bring you anything from the United States? Okay, here is the video. Okay. Wait a second. Wait.
¿Cómo saber si un átomo es estable? En este vídeo vamos a aprender sobre la desintegración
radical. The video came in Spanish. That's a good question. I wanted the video to be in English, and I'm using Fuse School, and it came in Spanish. Honestly, today is really not my day. I just need to finish the day as soon as possible, clearly. All right. So I bring you food? No, I would not bring you any food. And actually, I don't think the food in the United States is better than the food in here. You're funny. Do you want me to bring you like a hat? Or like a flag or something like that?
What is the biggest problem you face as a college student?
Being stressed out about all the things that I have to manage and deal with.
Definitely time management.
For me, like writing has always been an issue. Like I journal a lot, and honestly, if someone were to steal my journal,
why the hell the ads are coming like this? All right, let's forget about the video because the computer is sabotaging me today. And now another. You are talking about advertisement. Are you honestly seeing what is happening in YouTube nowadays? It's impossible to watch anything without having like 5 advertisement. honestly, I am even considering having YouTube Premium at this point, because using YouTube is just ridiculous, honestly. All right, so let me show you now my screen. Okay. No, I'm not joking. It's just crazy. The amount of advertisement nowadays in anything you use is just crazy. Okay, 3, 2, 1. There is the video. Well, there's supposed to be the video, actually. Okay. Can you tell me now? Wait a second. Once that whole screen green color disappears, you see how slow it is? It is so slow. I would need a gaming laptop one day.
We saw in the last video that each element comes in a number of different forms called isotopes, each of which has the same number of protons,
okay,
but a different number of neutrons.
Question, can you hear it? Can you hear it? Can you hear the video? Yes or no, guys? Could you please tell me if you can hear the video? I mean, when I play, obviously. All right, thank you. All right. So I will skip
Importantly, though, only one or two of an element's isotopes
I will skip the part about isotopes because we have been discussing and read about it. So it doesn't make any sense if we talk about it. I want to just pass to the different types of radiation, okay? So you can have an overview of the 3 different types of radiation, how they look like, and how is their properties, okay? All right.
Let's start with alpha.
There it is.
In this video, we're going to take a closer look at the 4 types of nuclear radiation.
It's saying 4, but for us it's only 3, okay?
Namely alpha particles, beta particles, gamma rays, and neutrons. And we'll cover how...
Ignore everything that says about the last one, neutrons. We don't need to know that for our GCSE.
ionizing, and how penetrating each of them are.
Ionizing is how easy, how easy those radiation they can make ions, which is something you have studied in chemistry, what is an ion, and how penetrating is how much they can pass through things. That is the meaning of penetrating in this context, okay?
Let's start with alpha radiation. Alpha particles are made up of 2 protons and 2 neutrons.
So it's comparing with other particles a very large particle.
Which is exactly the same as the nucleus of a helium atom.
It's like a nucleus of a helium, so it's like helium nucleus, but without the electrons.
So we normally represent alpha particles with helium's nuclear symbol, He.
No,
Importantly though, alpha particles don't have any electrons. So they have an overall charge of 2+. From those 2 positive...
They are positive particle. That's why when the alpha particle gets nearby the nucleus of an atom, they repel. Like it happens in the gold foil experiment, which is one of the 6-mark questions that you need to know for your GCSE, the gold foil experiment.
Protons. Because they are relatively large, alpha particles are easily stopped by collisions with other molecules, which means that they can't penetrate very far into other materials.
Actually, if you want to protect yourself from alpha particle, the only thing you need to do is this. By doing this, lifting the paper and covering my face with the paper, alpha particles cannot touch my face. Their penetration power is very, very, very little.
In fact, they can only travel a few centimeters in the air.
You see?
And are absorbed by a single sheet of paper.
I promise, this video is not mine.
However, their large size and their strong charge does make them very strongly ionizing, which just means they can easily knock electrons off any atoms that they collide with. Next up,
if you want to look for stuff that emits alpha particles, the smoke detectors, they are made of one element called americium, and they emit alpha particles. I'm looking in my room. I don't have any smoke detector, but I'm sure if you go to your kitchen, you will find smoke detectors.
Up, we have beta particles, which are just electrons. So they have a charge of -1, and virtually no mass. Now, the weird thing is that electrons aren't emitted from one of the atom's shells. Instead, one of the atom's neutrons decays into a proton and an electron. The proton stays in the nucleus, but the electron is emitted out at high speed.
That's why makes a beta particle or beta emission quite dangerous, because when that electron is emitted, that could collide with your cells and with your DNA, and that can end up in a mutation. All right, that is what makes radioactivity dangerous. The interaction between these alpha particles, beta particles, or gamma particles with our cells, that can end up in having a disease or having a mutation. I'm losing viewers every second. Oh my god.
Because beta particles are pretty tiny, they are moderately ionizing, and they penetrate moderately far into materials. For example, it would take several meters of air, or about 5 millimeters of aluminium to stop them.
That's why when you go to have an X-ray photography, which I assume that many of you have had an X-ray photography, they need to cover some parts of your body, because X-ray is basically beta minus, okay? So when, imagine they need to make like a scan over your body, they could cover your face, or they could cover your belly with certain metal, because the beta particle cannot pass through that metal. We're gonna finish with gamma radiation, and we'll finish with today's stream before I lose the viewers I have left.
Now, gamma rays aren't particles at all. They're actually waves of electromagnetic radiation, like light is. And they're often emitted after alpha or beta radiation, as a way of the nucleus getting rid of a bit of extra energy. As they don't have any mass or charge, they tend to pass straight through materials.
That is what makes them very dangerous. If you are exposed to gamma radiation, it will pass through all your body, and there is nothing to stop it. Where are we going to see gamma radiation? Well, we're going to see gamma radiation in nuclear power plants, in nuclear bombs, which I wish you would never witness. Gamma radiation, we will only see it in very high energy event, and as I mentioned, it is very, very dangerous because it cannot be stopped. It literally passes through any sort of material, any object. That is what makes it very dangerous.
Colliding with any of the atoms, which makes them only weakly ionizing. This means that they can penetrate really far into materials before being stopped. So it can travel long distances through air, and it takes thick sheets of lead or multiple meters of concrete to stop them.
Exactly. That's why the walls of a nuclear power plant needs to be protected with layers of lead and layers of concrete, because otherwise the gamma radiation could escape, and that is dangerous for people. Okay. All right, I will stop in here. Remember that all these three are the three types of radiation, and the type of radiation, and radiation happens because we have radioactive isotopes that they emit radiation to become stable. That's the key idea. If you need to live today with one key idea, is that radioactive isotopes, they are isotopes that they are unstable. And in order to become stable, they emit radiation. That is the point of radiation. And the three types of radiation, they are called ABC, alpha, beta, gamma. Alpha is a fat particle made of protons, 2 protons and 2 neutrons, and it can only travel a few centimeters, and it can be stopped by a paper. Beta particle, that is a high speed, high energy electron that can be stopped with aluminium. And gamma particle, gamma radiation, which is not a particle, is electromagnetic radiation, and it is not stopped. Okay? Easy peasy, lemon squeezy. This is one lesson that you will have in school, okay? And we have done it in less than half an hour. I hope you enjoyed. The topic of radioactivity is fascinating. It's the sort of topic that students or do very well or do very bad, okay? But it's a topic that in my particular case I find fascinating because you can connect it easily with geography, with history, with politics. It's very fascinating. They don't really need to know about neutrinos and bosons. Tell me, what is your question? What were we learning today? Today we were talking about isotopes and radioactive decays. Okay, that was today's focus, and the 3 types of radioactive decay. That was the focus of today's session. Okay, that was the focus. And remember, the key idea I want you to leave today is that radioactivity exists because radioactive isotopes, they want to become stable. Okay? They cause us disease because when those particles, they interact with our cells, yes, they can break the DNA, and that could lead to a mutation. And a mutation could lead into a tumor, or a tumor could lead into a cancer. That's how they are dangerous. Okay? Does it make sense? I hope it does. If not, we can continue talking about this next lesson. All right? Oh, one day we need to talk about that practical. What a massive disaster. It's all, I cannot say the name, but we all know whose fault was that. No, being exposed to gamma radiation is not good for your health. Okay? It's not something you should do. Definitely no. Stay away from radiation as much as possible. Okay? If possible. Which sometimes this is not possible because we are exposed to radiation every day. When we are under the sunlight, we are exposed to radiation. Can I eat alpha particles? No, you can't. Because if the alpha particle gets inside your body, they can be dangerous, okay? Alright? Alright guys, as I promised, I will now continue my lesson. I will actually change the title of now session. I will close the session and I will open a new one, and I will focus into A level. So you obviously can stay, but we are gonna solve some A level exam questions because your older brothers and sisters, they have exam tomorrow. You're welcome to stay, but be aware that it's a bit hardcore, it's a bit difficult, it's a bit heavy, so it could cause brain bleeding probably. Okay, when I mean brother, I mean the years above you. Okay, because we are all part of the community. It's a metaphoric language. It's not a literal language. Okay. All right, guys. Thank you very much for your attendance. I hope you enjoy. I hope you learn about radioactivity. And now I will go close this one, open a new one, and get into A level. So see you soon, guys. Bye bye. There were 3 difficult questions, to be fair. Bye bye.